Mr. Tarrou, in this algebra lesson, we are going to be looking at solving, at least for a variable, literal equations and formulas. Now, a literal equation is simply an equation that has two or more variables in it. So we're not going to solve these equations and know that, x is equal to 10 and I can plug that 10 back in and see if the two sides match. No, we're going to do 4 examples, and when you're working with these literal equations, that has two or more variables, you're just, manipulating the relationship, the left and the right-hand side of the equation, and rewriting it here like we've got the perimeter of a rectangle, instead of just rambling on. We've got the perimeter of a rectangle. Well, how do you find the perimeter of any geometric figure? Perimeter is just the distance around the outside of an object. If it's a circle, that perimeter has a special name. We call it the circumference. So if we just have a simple rectangle, we start at one corner, and we want to figure out the length, how far it is to get all the way around the outside of that rectangle. We could be talking about the length of a sidewalk around a park, the length of baseboard around a room, if you install screens, how much of that black piping, I don't know what it's called, but how much of the black piping do you put around the outside frame of that screen to hold it in, just for some application problems. Well, the perimeter of a rectangle, since we have to get around all 4 sides of this rectangle to get back to where we start from, we have 2 sides of length L and 2 sides of length W. So the perimeter is equal to 2L plus 2W. And I want to take this equation and I want to solve it for W. I want to get the W by itself. And why would I want to do this? Well, I'm just going to simply do it because my teacher asked me to. Maybe I'm setting up an Excel spreadsheet for some kind of business application, and for some reason, I want to have a cell in that box that when I enter the perimeter and the length of a rectangle, it just can automatically tell me what the width is. There's a lot of use of formulas, literal equations, in Excel spreadsheets for applications in the business world, just again as an example. So we want to solve this for W. At first, sometimes literal equations can be confusing for students because, we're used to just, especially when we start solving linear equations like we've been doing lately, we only have one variable in it and we're moving numbers. And that's arithmetic is something that you've been, learning how to do since you were in, 1st or 2nd grade, right? So all this algebraic idea can be very abstract and therefore confuse students. But a variable, again, is nothing more than a number. And if you look at this and you're not sure how to solve it, well, I'll tell you what, if you can solve this equation, let's, put it in yellow. 10 is equal to 3 plus 2x. How would you solve this? Well, the variable's on the right-hand side of the equation, just a simple 2-step linear equation. Well, we need to get the 3 and the 2 away from the x, which is on the right-hand side. Well, the 3 is over here on the right, with the x on the right side of the equation. We need to move it to the left. We need to do the inverse math operation to get that 3 to move to the left side of the equation. Well, it's a positive 3. So we would subtract both sides by 3 and get 7 is equal to 2x. Maybe it wasn't a good idea to have my dividing line be the same color as my work, so let's get that line out of there. Well, how am I going to move, getting back to our actual problem here, our literal equation, when we're trying to solve this for W, the W has an attached, has a 2 attached to it. Well, it's attached with or combined with the 2 through multiplication. And remembering our steps of solving our linear equations, we want to save that last step, that division, for the end of the problem, so we don't create any extra fractions that we need to deal with through the rest of the problem. And we have this 2L, this standalone term. It's over here on the right with the W. We're trying to solve for W, so we're going to move that 2L over, that entire term, which is just over here. There's kind of like nothing out front, so it's a positive 2L, if you will. And it's on the right-hand side with the W. Well, we had a positive 3. That's a term. It's a term which we know. It's a constant. And the opposite of an addition of 3 that we have on the right with the x is a subtraction of 3, or inverse. So we're going to subtract both sides by, we'll pick a color here I haven't used yet. We're going to subtract both sides by 2L. Okay, a variable is just a number which we don't know. If I told you that L was 5, then 2 times 5 would be 10, and we would know that we would want to subtract, that 10 from both sides of the equation. So hopefully that tie-in with this sort of less abstract example, something that we've been working with recently, and seeing that positive 3 and moving it over with subtraction kind of explains why I'm just taking this positive 2L and subtracting it over. And I'm saying positive 2L because there's nothing in front of this term. Really, I don't know what L stands for. It is a number which I don't know. And maybe L is a negative number and this term is negative. So anyway, just hopefully allow me to say that subtraction. So we have P minus 2L is equal to, well, 2 minus 2 is 0. You know, combining or subtracting those coefficients, and 0L is simply 0. Or that 2L is canceled out, if you will, because we've moved it to the left-hand side, and we have 2W. So again, now we have P minus 2L is equal to 2W. Well, over here, the 10 and the 3, those were like terms. There's no variables. These are both constants. Neither one of these terms have a variable. Like terms are terms which have the same variables in them and the same number of those variables, and we just combine them to get the answer of 7. Well, please note that I did not do 1 minus 2 and write negative PL. These are not like terms, so while I can write them on the same side of the equation, I can't really combine them. They're just sitting over there hanging out by the, together, but not like, next to each other, but not really together. Now I want to, let's see here, if we had 7 is equal to 2x, I would want to undo that multiplication of 2 with division, so I would divide both sides by 2 and get 7 over 2 is equal to x, or you might write 3.5. I prefer the fraction if you were my student in a regular or honors class. Well, over here, we're going to divide. We want to undo that multiplication of 2, just like we did over here, with division. So we're going to divide every single term by 2. And I can write my division of 2 this way, where every single term gets that division of 2. Sometimes I do prefer to write that. And our final answer is going to be, well, 2 divided by 2 is equal to 1. So we have W is equal to P over 2 minus 2L over 2. And again, sometimes showing that division with each of your separate terms is the best thing to do. But now maybe if you're doing multiple choice and you have to choose the right answer, each of these fractions have the same denominator, of course. It's the division of 2 that we just did. So we could also write, when you subtract fractions, if you have a common denominator, you can just write that common denominator once and say that it's P minus 2L over that common denominator of 2 is equal to W, which I don't know why I'm writing it like that, but which is equal to W. Now, I could have gotten to the same ending point here, P minus 2L over 2, if on the left-hand side of this equation, instead of writing a separate division sign for each term, I just wrote one big division symbol and, wrote that over 2. So you just have an option of how you write your final answer with this problem. Now, again, like I mentioned before with the Excel spreadsheet, I've got W, basically the width of the rectangle, being explained or described by the overall perimeter of the rectangle and the length. So if I have a particular rectangle that I know whose perimeter is 30 and whose length is 2, I could put in 30 and 2 and work out this arithmetic and know that the width, I'm kind of nodding my head around because I would just work out the arithmetic to find W, which would be great if you're doing an Excel spreadsheet, but you could also put in the perimeter and length here and hopefully solve for W. Now our second equation here, we've got that C is equal to 5/9 parentheses F minus 32. And you might look at that and just think it's a random formula that's in your textbook, but it is a formula that converts Fahrenheit into Celsius. But if I want to turn this equation around and have it convert Celsius into Fahrenheit, solve for F, what would I do? And there's a few options you can do for this. If you want to solve for F, you can distribute the 5/9 through the parentheses. We do that often. But we can also look at it as, hey, this parentheses is holding this f minus 32 together. This is all just one term. And sort of like if this is my variable, well, if I wrote, let's say 3 is equal to 5/9 x. If I said solve this equation, one term and one term, well, there's one term here and one big term here. This looks a bit more complicated than this, but it's 5/9 times something. I could multiply, or hopefully I would, multiply both sides by 9/5, the reciprocal of that fraction. And, you know, the 5 divided by 5 and the 9 divided by 9 would cancel out, or my 45/45 would cancel to just simply give me 1, and x would be alone, and it would equal some kind of number, and I would be done. And that's how I want to start this problem. I don't really want to distribute 5/9 through the parentheses, just because it's going to cause a little bit more work. So let's do 9/5 times c is equal to 9/5 times 5/9 f minus 32. And so I'm applying that same math operation of multiplying 9/5 to both sides of the equation, but you're only going to see that multiplication occur once on the right side, because there is only one term here. If there was a bunch of terms, then we would have to distribute that 9/5 to all of those individual terms. But the 9 and 9, we're going to cancel across this multiplication sign. So 9 divided by 9 is 1. Those 5s are going to cancel out, and so this is all going to cancel out to be 1. And when you multiply, you know, if I just have a coefficient of 1 in front of these parentheses, then I would distribute the 1, but then nothing would really change. 1's the identity for multiplication. So we have 9/5 c is equal to f minus 32. We don't need the parentheses anymore. And now the last thing with the f is the subtraction of 32. So we're going to add both sides by 32. Again, I'm stacking this on the left-hand side, but these are not like terms, so they're not really going to go together. And we have 9/5 c plus 32 is equal to f, and we have taken a formula, a literal equation, that converted Fahrenheit to Celsius to another equation, a new equation, that would convert Celsius to Fahrenheit. And so there's our first 2 of 4 examples where we're going to do this solving or working with literal equations. Next example. Back again. Our last 2 examples are 4a minus 3bx is equal to x plus 7. And our last one is going to be a is equal to whatever. I'm not even there yet. Why am I talking about it? And for these last 2 examples, these aren't really application problems per se, like working with a relationship between perimeter and length and width, and especially that Celsius and Fahrenheit example. They're just a couple of examples that I picked because I see some difficulties in problems that my students will deal with later that I can start to talk about in these 2 problems. This one is going to recall the skills that we used recently, solving linear equations with the variable on both sides. You can't solve for x when it's on both sides of the equation. You cannot isolate it when it's on both sides. So we need to rearrange these terms so we can, to fix that. And keeping with the idea that we're just going to do one step at a time, let's go ahead and I know I'm going to do a lot of work with the terms with the x's, and why not avoid as many negatives as possible. So I'm going to move this negative 3bx over to the other side, and remembering that when you're moving an entire term, like you saw me do in the previous 2 examples, I compared it to a more, a single variable linear equation as a comparison. But when you do move entire terms, you want to do that with addition or subtraction. So we're going to see that this term is sort of quote-unquote negative, and add that to both sides. I say quote-unquote because I don't really know what the variables of b and x represent, and maybe the whole thing ends up being negative or positive, I don't know, but okay, so we're going to add 3bx to both sides, the inverse math operation of that negative, and we get 4a. And actually, many of you are probably going to be comfortable moving in a couple of terms at the same time, but I'm just going to do one step at a time. We have 4a is equal to x plus 7 plus 3bx. Okay, now our right-hand side of the equation has a positive 7. I need to isolate those terms that have the x in them if I'm going to continue to solve for x, just like I did before when we had this sort of similar idea where we had an equation with variables on both sides, and we get 4a minus 7 is equal to x plus 3b x. So now that I'm kind of continuing this problem on here, let me make sure. Okay. I wasn't sure if I had any issues with the domain in the final answer of my previous example. I will in this one. Now, we've got a variable here. I'm trying to solve for x, right? Now, not only are we seeing how we're moving terms around like we had to do before when we had variables on both sides of a linear equation, but we can also see that we have a variable in two terms. Okay, let's see. How am I going to best explain that? How do I rewrite this so that I can write x only once? Hopefully you can see that both of these terms have an x in them, and you understand how to factor out a monomial. If you're not sure how to factor or you're weak on your factoring skills, I'll put a link to a playlist which is specifically just about factoring. And if you can see that, then what we can do is simply say, well, we have 4a, I'm going to explain this another way as well, by the way. 4a minus 7 is equal to, okay, both of these terms have a common factor of x, and if I recognize that these both have a common factor of x, I can factor out that monomial and write that I'm going to take that x out, and we're going to factor out that monomial through division. So we're going to have x over x plus 3b x over x, just in case everyone or anyone needs to see that process of, how do you factor out that term? How do you factor out that common monomial? Excuse me, not term. And we're going to do that through division. Now, I'm showing that there's going to be a multiplication of x. The inverse math operation of multiplication is division. So, right, I'm showing that's going to change the look. But since I'm using inverse math operations, I'm not going to change the answer because x over x is 0. Or excuse me, x divided by x is 1. So I'm changing the appearance of this, but I'm kind of almost showing a multiplication of 1, so I'm not going to change its overall value. And that is going to be 4a minus 7 is equal to x divided by x is 1. 3b x divided by x, those x's are going to cancel out. And x divided by x is 1, so we have 3b times 1, so it's 1 plus 3b times x, and we're almost done. Now, if you need to understand how to factor out a monomial, but another way of looking at this and explaining how that x is coming out and you can just go ahead and just write it once, think about adding like terms. There's no like terms in here, so let me give you a simpler example. If we have 2x plus 3x, you probably now are just automatically saying that that's equal to 5x. But when you first were taught, more than likely by your teacher, that when you when you add like terms, it's kind of the same idea with factoring here. You learn the distributive property and how to quote-unquote undistribute. That's another phrase for this. Factoring out a monomial is sort of undistributing. And I can say, well, again, with the same idea, these both have an x, so I could take that x out through this process of factoring out a monomial or undistributing, and we get 2 plus 3. I'm not going to show the division again, but 2x plus 3x, I can take that common factor of x out. Then I'm just left with, inside my parentheses, a 2 plus 3. Well, that's where the 5 comes from, of course, and we get an answer of 5x. So textbooks will, at least many that I've seen, will show the addition or the combination, addition, subtraction of like terms through this undistributive or this factoring process to show you why or how simply 2 plus 3 gives you 5. And you can see here with this simpler example again, I have two terms that both have an x, and when I rewrite it, I've got the 2 plus 3 left in the parentheses, and I'm only writing the x once. Okay, so now we have 4a minus 7 is equal to 1 plus 3b in parentheses, locking all that together, times x. That would be like the 5 before, except these are not like terms. They don't really go together. How do you undo that multiplication? How do you move that factor of 1 plus 3b away from the x? Well, you're going to do the inverse math operation of multiplication again, which is division. I really shouldn't be writing all this work in orange because going to do the next problem in orange. So my apologies for that. We're going to divide both sides by 1 plus 3b. And really, you know, anything divided by itself, even when it's a little bit complicated like this, those are going to cancel out, giving you just, well, they're going to divide out to be 1, and multiplying by 1 doesn't change anything, so it's going to appear to just disappear, but it's going to be 1x, we would just normally write x, is equal to what you see here, 4a minus 7 over 1 plus 3b. Now, I'm not sure if in an algebra book your teacher is going to be, you know, having you check the domain of your final answer, but, you know, what would be the domain of this expression? Yes, x is equal to 4a minus 7 over 1 plus 3b, but if this is your expression, there's going to be a possible issue with that 1 plus 3b that we have down here in the denominator. You have a division, and in the division, in the denominator, you have a variable. Well, if you have a variable in your denominator, you're leaving open the possibility of dividing by 0, and you cannot divide by 0. So with our final answer, 1 plus 3b cannot equal 0. So let's solve this for b. This is a two-step equation. We're going to subtract both sides by 1 and get 3b cannot equal negative 1. Continue to solve for b by dividing both sides by 3. And b cannot equal negative 1/3. So if your final expression, your final answer when you're solving for x is that we have 4a minus 7 over 1 plus 3b, well, b can be anything really as long as it's not negative 1/3, because if it's negative 1/3, this expression ends up being 0. You can't divide by 0 and that expression is undefined. Now if I'm just doing Algebra 1, probably just very happy that my students have correctly solved for the variable which is requested, but a little bit of an extra piece to this problem that you might want to consider. Now over here, oh, let's see. I've started it in orange. I guess I'm going to go ahead and do it in orange, but I'll do everything in orange here to kind of differentiate here. Maybe, I don't know, whatever. So pick another color. I want to solve this for C. We're almost done. Am I rambling on? I want to solve that for C. Okay, well, C is inside a set of parentheses, all right? Now, that means I need to get the C out of the parentheses. Now, how am I going to get rid of those parentheses? Well, there's a few things I can do. I can, again, take the D and multiply it through the parentheses. And if I do that, it would look like this. A is equal to D over 1. I don't really like this method the best, but it's a possibility. I have a set of parentheses, a multiplication. I'm going to distribute through the parentheses and get BD plus CD over 3. Right? Because 3 times 1 is equal to 3. And now I can undo that division of 3 by multiplying both sides by 3. And we get 3a. I was going to just set this problem up, but I think maybe we'll just, you know, take a nice long look at it, and we'll just do this last example twice. When you're working with fractions, you really should make everything look like your fractions so you can see how those numerators and denominators line up. So those 3's are going to cancel. That is my doggy. And we get the 3's cancel, and we're going to get BD plus CD. We're trying to solve this for C. And so there's our variable. We have a term over here of BD with it, and so we're going to move that from the right-hand side of the equation over to the left, again with subtraction. These are not like terms, so we have 3a minus BD is equal to CD. And our last step is to undo that multiplication that we have with the C, trying to solve again for C. Let's highlight that because that is what we're trying to get alone. We are going to isolate that C by canceling out the multiplication of D, getting the D away from C by dividing both sides by D. And our final answer is 3a minus BD over D is equal to C. And you're like, maybe you're like, that isn't what I would do. I would have done blah, 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 blah. Well, yeah, a lot of problems in algebra have multiple ways of solving them. And since we have so many variables, and it's not just sort of like, oh, there's an x in the variable, there's just an x in the equation, let's solve for x, and everyone gets the answer of x equals 2. You can have an issue where you do everything right, but your answer looks a little bit different. It looks not quite the same as everybody else's work. Now, I'm not sure if my final answer is going to look any different, but what if we go back to our original problem? A is equal to b plus c over 3 times d. We're trying to solve this for c. Another way of sort of eliminating the need of those parentheses is to undo the multiplication of d that's with it. So I could have just started this problem immediately by saying, oh, I want to cancel or undo, get that d away from the parentheses. I want to undo that multiplication of d. So let's go ahead and divide both sides by d. And that is going to cancel, that division of d is going to cancel the multiplication of d that's on the right-hand side. Again, because the parentheses are holding all of this up together as one term, so there is only one term in the numerator here, so you don't have to cancel the d out once. And we get a over d, is equal to b plus c over 3. And you might go, ooh, that's one fraction equal to one fraction. Let's cross multiply. Well, if I do that, I'm going to get right back to where I started from. If I cross multiply here, I'm going to get 3a. And then I'm going to have to do d times each of the terms in the numerator, and that's going to be the distributive property. And I'll be right over here where I was in orange. But that would create more work to my problem that maybe I would like to not necessarily do. So now I'm going to see that there's a division of 3 here. There's only one term, and there's a division of 3. And if I don't want a division of 3, a denominator of 3, then I multiply both sides by 3. And so we have 3a over d is equal to, well, these 3's are going to cancel out because your numerator and denominator, you can cancel factors, not terms, but you can cancel factors across the multiplication sign. So we have b plus c, and I'm trying to solve for c, so I'm going to subtract both sides by b, and we get 3a over d minus b is equal to c. Bam! I'm done, right? And I am done. But you might look at that and go, those don't look the same. Well, they don't look the same. And if it's a free response question, both of these answers are going to be acceptable to your teacher, I'm sure. But if it's a multiple choice question, one of the multiple choice answers might look like this, and one of the multiple choice answers, or, well, you're not going to have both choices at the same time because they're both right, but you might have this as a multiple choice answer to choose from, or it could look like this. These are equivalent answers because if I come over here and go, hey, I want to write these two terms to be just one term. Well, if I combine fractions, don't I need common denominators? Which means I would have to go here and see, well, this denominator is d, this denominator is simply 1, so I need to multiply the numerator and denominator by d, and look at there, 3a minus bd over common denominator of d. And that is the end of my last example. I'm Mr. True. Go do your homework.